Welcome to this session on integration between Structured Data Manager, SDM, and Voltage. Today we're going to look at the ability for SDM to unlock encrypted data, specifically for authorized users using data access cartridges. My name is Brian Majora, and I am a pre-sales solution architect operating in North America for the Security, Risk, and Governance Organization. As far as an agenda, today we're going to look at the typical risks and costs faced by customers, an overview of how SDM Voltage solution can address and mitigate these risks and costs, and then we'll have a standard demo of the encryption, touch on the discovery using SDM and Voltage. And then the last thing we're going to do is show you some of the new functionality that we've developed in-house, a productized integration between Voltage and Structured Data Manager that allows a data access cartridge to selectively decrypt encrypted data, specifically though only for authorized users. So let's get started on the first part of our agenda. So all of our customers have databases, structured data that typically support fairly narrow silos within their organization. They'll have HR database, finance databases, marketing, CRM, orders databases that support those lines of business. Each of those databases will have specific specialists that understand the nature of the data held within those databases. The problem, though, is that through mergers and acquisitions, companies often start to acquire additional databases, or they have older versions of databases that they've migrated off, but they need to retain and keep those old legacy systems for reporting purposes. From a data privacy perspective, the risk of the data held within those systems is extremely important for regulations such as the California Consumer Privacy Act or the GDPR regulation out of Europe. With those new regulations and the new focus on data privacy, all of the data held within those databases essentially becomes a risk to the organization, all of the sensitive data within them. To address that risk, the corporation would need to go out to each of these stakeholders, each of these specialists in their specific domain and ask, what type of sensitive data is held within each of these databases? So the result of that is obviously going to be very inefficient. The effectiveness of that is going to be in question. Each person is going to give different types of answers back, subjective answers due to the nature of asking that question to many disparate users. So add to that, over time, the intellectual property of those specialists can start to disappear as people retire or move out of the organization, making that task even harder to manually determine. So how can we address these issues around risk and cost? Structured Data Manager plus Voltage can be used to scan each of the databases and categorize all of the information by their personally identifiable information, by the sensitive nature of the data within them. The SDM dashboard allows a select group of individuals to review the results in a dashboard, thereby looking at so that they can quantify and qualify where the sensitive data risk lies within those databases. And then using the integration between this SDM and Voltage, we can then take action by mitigating the risk by encrypting specific columns of data held within those databases. We might find after doing this scan that certain databases hold no sensitive data or low amounts of sensitive data, thereby removing those databases from consideration from a risk perspective. Or we can start to archive databases off, thereby addressing the cost side of the challenge customers face. Either way, we can either encrypt that data in place, or we can extract the data and encrypt it and hold it into an archive for safekeeping. So from a process perspective, on the left, we have a user that uses an application, a SQL-based application built upon a database. Using Structured Data Manager, the first step that we will do is connect to that database through JDBC and perform our scan. That's going to allow us to locate all of the personally identifiable information or sensitive data, categorize it, and quantify the risk. That's all done through a GUI interactive dashboard using that we call Discovery within Structured Data Manager. The second step will be to take that information we glean from Discovery and start to design an action that we're going to take, design a mitigation. So using our Structured Data Manager designer interface, we can then determine what fields to encrypt and how to encrypt them. And then the last thing we will do is deploy that design solution to our SDM web console, which is the engine of Structured Data Manager, and execute that action, take action. So in this case, we can either encrypt the sensitive data that we identified through Discovery in place within the production database, or we can extract that data and put it into an archive at the same time, while at the same time encrypting it using the integration with Voltage. We're going to encrypt that data using what we call format preserving encryption through the Voltage SecureData server, which, as it implies through its name, means the data will be changed, encrypted, but will retain the original format. That means a credit card data value will still look like a credit card data value, even though it's been encrypted. A last name will have the same amount of characters in case sensitivity as the original data, but be encrypted and unreadable by an authorized user. Focusing on the archive use case, where perhaps we have a legacy system that's no longer been used, it's been replaced by another system, and all of the data within that legacy system is read-only, we can extract and retire the data from that application. So what that use case looks like, we start with an application, SQL-based, that's based off a relational database, and users use that application to view data within the database. Using Structured Data Manager, we'll extract all of the data out of the database and encrypt that data as appropriate using FPE, format preserving encryption, through our integration with Voltage. We now hold that data within an archive. It can be a file-based archive, or it could be a second database. That allows us then to get rid of, essentially retire, the original database and all of the data held within it, and retire the application. So in this state, the data is held within our archive in an encrypted format. This is an example of what that may look like. So in the top, we have the original production data in red, and in the bottom is the resulting encrypted data set that we hold in our archive. You can see names have been encrypted with the same number of characters, the same casing. In this case, the social insurance number, we've chosen strategically to encrypt the first 5 digits, leaving the last 4 in the clear. Credit card, similarly, we've decided to encrypt the middle numbers, leaving the beginning and the end in the clear. Street address has been encrypted, maintaining its format. Customer IDs have been encrypted. We've chosen to leave state and score in the clear in our encrypted archive. So now we have an encrypted archive and we have a user. To replace the application that we retired, we introduce a new concept from Structured Data Manager called a data access cartridge. Now, a data access cartridge is a visual HTML interface that a user can use to query the archive, much like they did originally using the application. So now a user is using a data access cartridge, which issues SQL-based queries against the archive. That on its own, if they did that, what they would see back is encrypted data. So anybody coming along and issuing SQL against this archive, they are going to see the encrypted protected data. What we can do, though, is introduce our further integration between SDM and Voltage by integrating the data access call with the voltage server combined with Active Directory. So a user coming through our data access cartridge is going to issue a SQL command to view data from a table, from an encrypted table. We're going to intercept that command and actually pass over the LDAP credentials of the user and the shared secret, as well as the identity that was used to encrypt that original data. That gets passed to the voltage server, which then looks up that user based on their LDAP credentials in the Active Directory to determine what their user identity or key names that they have, which are recorded within the LDAP Active Directory. If the user has the right identities, the appropriate identities held within Active Directory to be able to see specific data, Voltage Key Server will pass back a crypto key back to the data access cartridge, allowing that data access cartridge to then decrypt the data held with that they've been asking for. If the user does not have the right identity, they will see encrypted data only. So what we end up with, we had the original data, which was then extracted and encrypted into our archive. Two users come along using our data access cartridge. The first user, Gary, he works in the finance department. So typically Gary is allowed to see the credit card information. In the LDAP server, Gary will have the correct identities for seeing finance data. So when Gary issues a query to see the information held in this customer table, he will see the decrypted name, the encrypted social security number because he does not have the SSN identity, and he will see decrypted credit card number, as well as decrypted information for the rest of the record. So in the end, Gary is not allowed to see the social security number. So if he issues a SQL query against the database using a data access cartridge, this is what Gary will see because Gary belongs in finance. Eric, however, works in HR. If Eric executes a query through the same data access cartridge through SDM, Eric will see the social security number, but will not see the true credit card number. He does not have the right key to unlock the credit card data. So Gary ends up seeing encrypted credit card data, but decrypted social security number because Eric operates and belongs to the HR group. So let's have a little demo and see how we actually achieve this functionality. So let's see this in action through a demo on our demonstration system. I want to log into the Structured Data Manager web console as an administrator. So I've already gone in and performed the data extraction and encrypted the data, which is now held in our archive. Going into a data access cartridge, as an administrator, I can run that data access cartridge, which is going to query the customer table. And let's see what we get back. The way I've designed this data access cartridge is I have 3 columns, last name, social, and credit card, which show the raw data of what's actually held in the database. So you can see the last name here, these have all clearly been encrypted. The social security number, it's obviously been encrypted. It doesn't even look like one. The credit card number as well, same number of digits, but it's all been encrypted. I've chosen to encrypt both of these using what we call an obviously encrypted format. So just by looking at it, I can tell that it's encrypted. The next 3 columns here, customer LNAME voltage, customer social security voltage, customer credit card voltage, is our attempt to decrypt the data that is being retrieved from the database. So you can see the last name actually in the database is this value here. Our attempt to decrypt it was not successful. It's still encrypted. Same thing, the social security number is unchanged. The credit card value is unchanged. And the point here is that I I'm running this data access cartridge as an administrator. The key here is that it doesn't matter who you are, a DBA or any user. If you do not have the right identity, the right shared secret, and the right LDAP credentials, you will not be able to decrypt the data. Let's log in as two of our use case users, Gary and Eric, and see the behavior when I try to run that data access cartridge as them. So logging in as Gary, running that exact same data access cartridge. And remember, Gary was in finance. So we would expect Gary to be able to see the credit card, but not be able to see the social security number. Again, you can see the raw data in its encrypted format that's held within the database. Gary does have the identity to be able to decrypt the last name. Gary does not have the identity to be able to decrypt the social security number. So even though the data access cartridge asked to see the decrypted social security number, it passed Gary's credentials through. Gary did not have the right identity. Gary cannot see the social security number. But credit card number, that was decrypted. Gary does have the credit card number, identity, or key name in the LDAP server. So when Gary asked to see this data decrypted, the Voltage server looked up Gary in LDAP, determined that he does have the identity, and then passed back the correct key, allowing the data access cartridge to decrypt the data as it presented here. Let's have a look at the behavior for Eric. So Eric comes in. Eric belongs to the HR group. We would expect Eric would be able to see the correct social security number. So using this same data access cartridge, it asked for and tried to decrypt this column, and it was successful because Eric belongs to HR in the LDAP Active Directory. But Eric could not see the credit card field for the same reasons. So that's the outcome. That's the solution in action. How do we get there? I'm going to need to log back in as the administrator to show you how we set up some of this within the web console. So from the web console dashboard, we have the settings tile. We'll go into there, and we're going to look at the masking server. In here, this is where we set up the integration between Structured Data Manager and where the Voltage appliance is, what the default identity will be used when an administrator needs to issue an encryption routine against the data. We test the connection to make sure we have a good path between SDM and the Voltage server, and we do. When I hit the apply button from this screen, it's going to reach out to the Voltage server and download all of the formats that are currently on that server and available by on that Voltage appliance. So example here, we have a credit card format called CC, leading zeros, trailing 4, ID. The key here is this identity column. These are each of the identities that will be used when we encrypt a column with this specific format. So this identity, SDM_CC_ID at scm.net, will be used by the simple API, by the Voltage simple API, when we do either an encryption in place within the production database or encryption of an extracted data set to an archive. So what this means is a user that wants to see the credit card value in this case, we know that it was encrypted using this format. We know it was encrypted using this identity. The data access cartridge will pass the format name, it'll pass the shared secret, and it will pass the LDAP credentials of the user, and it will also pass the identity. Okay, so going back to that slide from before, by the data access cartridge passing all of that information over to the voltage appliance, it then looks up that user in the Active Directory, finds out what the user's identities are, or key names they have logged against, they have recorded in LDAP, and they try to see if that key name that they have in LDAP matches this key name or identity which was used to encrypt the data. If the user does have this identity in LDAP, then they'll be able to decrypt it. If they don't, they won't. So once we've designed and developed our in-place or data extraction cartridge, and we've determined which columns will be encrypted with which formats, with their underlying identity and shared secret, we deploy that cartridge from Designer, and we execute that cartridge within the web console. That gets us to where we are now. The data within the database is fully encrypted and secure. To see that data, we would create a data access cartridge in Designer that makes calls that asks to see a column, but asks that column to be decrypted using the Voltage Simple API. So you can see I have the data access cartridge design in here, which is what we were running before through the web console. I have all my raw fields that are based off of the actual customer table, but then I have some groovy columns here within the data access cartridge that ask to see the data identified or decrypted or unlocked. So my customer CC voltage column, which is over here on the right, if I edit that groovy column, I see a very simple call, SecureData.access simple API, passes the format that was used, and remember, we know for this format what identities were available. So remember, we know for this format, we know the specific identity that was used originally when it was downloaded to encrypt the data. So it's going to pass the format name, the identity that was used, the LDAP credentials, and the shared secret, all through this SecureData.access call. So you can see from the design perspective in SDM, it's a pretty simple operation to design a call to decrypt data for an authorized user. So I hope you enjoyed this brief overview, which detailed how the SDM integration with Voltage can be extended to allow authorized users to view decrypted data through a data access cartridge. If you have additional questions, you can reach out to your local pre-sales solution architect or to the product manager for the SDM group. Thank you.